Inferential statistics is a statistical procedure used to draw inferences for the population on the basis of information obtained from the sample. The backbone of inferential statistics is descriptive statistics. With inferential statistics, you try to arrive at conclusions that extend beyond the immediate data alone. Key functions of inferential statistics. 1. Hypothesis testing. This is a core function of inferential statistics. It involves testing an assumption, hypothesis, about a population using sample data. For instance, an educator may hypothesize that a new teaching method improves student performance and test this assumption using a sample of students. By testing the hypothesis, researchers can determine whether the effect observed in the sample can be generalized to the broader population. 2. Estimation. Inferential statistics is used to estimate the values of population parameters, such as the mean or proportion, based on sample data. This is done using confidence intervals, which provide a range of values that likely contain the true population parameter. For example, an educational researcher may use a sample of student scores to estimate the average score of all students in a school district with a certain level of confidence. 3. Prediction. Inferential statistics can help in making predictions about future outcomes. For example, if an educational manager collects data on student performance and other variables, they can use inferential statistics to predict future student performance or outcomes based on these relationships. Techniques in inferential statistics. 1. T-tests, a statistical test used to compare the means of two groups to see if they are significantly different from each other. For example, a school administrator might use a t-test to compare the test scores of students taught by two different teaching methods to see if there is a significant difference in performance. 2. Analysis of variance. ANOVA. This technique is used when comparing the means of three or more groups. It helps determine whether there are any statistically significant differences between the groups. For instance, an education researcher might use ANOVA to compare the effectiveness of multiple teaching strategies across different classrooms or schools. 3. Chi-square tests. Used for categorical data, chi-square tests help determine if there is a significant association between two variables. For example, a school leader might use a chi-square test to examine whether there is an association between student engagement and academic achievement in different grade levels. 4. Regression analysis. This technique is used to examine relationships between variables. In educational management, regression analysis could be used to study how various factors like teaching experience, student-teacher ratio, and school resources impact student performance. 5. Correlation. Measures the strength and direction of the relationship between two variables. For example, educational leaders might use correlation analysis to assess the relationship between student attendance rates and academic achievement. Applications of inferential statistics in educational management. 1. Assessing the impact of educational interventions. Educational leaders can use inferential statistics to determine if new teaching strategies or programs lead to significant improvements in student outcomes. For example, after implementing a new curriculum, a school leader can use inferential statistics to compare pre- and post-implementation student test scores. 2. Improving resource allocation. Inferential statistics can help administrators identify which resources, e.g., training programs, teaching tools, are most effective in improving student performance. By testing hypotheses, they can better allocate resources that maximize educational outcomes. 3. Policy development and decision-making. By analyzing sample data from various schools, inferential statistics helps education policymakers make decisions that impact the entire educational system. For instance, educational managers can use regression analysis to predict how changes in teacher-pupil ratios may affect overall academic performance. Advantages of inferential statistics. 1. Generalization to larger populations. One of the primary advantages of inferential statistics is its ability to make predictions or draw conclusions about a large population based on data from a smaller sample. This makes it possible to apply findings to larger groups without the need to collect data from every member of the population, saving time and resources. 2. Hypothesis testing and decision-making. Inferential statistics allows researchers and educational leaders to test hypotheses and make informed decisions based on statistical evidence. This enables evidence-based decision-making, such as implementing new teaching methods or educational policies. 3. Predictive power. By using techniques like regression analysis, inferential statistics can predict future outcomes. For example, it can help predict student performance or identify factors that may influence academic success, helping educational leaders plan effectively. 4. Assessing relationships. Inferential statistics can identify relationships between variables, e.g., teaching methods and student performance, allowing for a better understanding of how different factors impact outcomes in education. 5. Cost-effective. Since inferential statistics relies on sample data, it reduces the need for exhaustive data collection, making it a cost-effective method for analyzing large populations. Disadvantages of inferential statistics. 1. Risk of sampling error. Inferential statistics depends on the assumption that the sample accurately represents the population. If the sample is biased or unrepresentative, the conclusions drawn may not be valid for the entire population, leading to errors in decision-making. 2. Complexity in analysis. Inferential statistics involves complex mathematical calculations and assumptions. Misapplication of these techniques or incorrect interpretation of results can lead to inaccurate conclusions. 3. Limited by sample size. The reliability of inferences depends on the sample size. Small sample sizes can lead to higher variability and less accurate conclusions, which may affect the validity of the results when generalizing to the larger population. 4. Over-reliance on statistical significance. While inferential statistics can show whether results are statistically significant, it does not always indicate practical significance. Educational leaders may overemphasize statistical significance while overlooking the real-world impact of the findings. 5. Assumptions. Inferential statistics often relies on specific assumptions, e.g., normality of data, random sampling. If these assumptions are violated, the results may not be valid, leading to misleading conclusions.